All right. So number one, the length of a rectangle is 15 greater than its width. If each dimension is decreased by 2 feet, the area will be increased by 106 feet total. So from here, this is the one where I mentioned I would definitely draw a rectangle. Not that it helps you necessarily mathematically, but it helps you keep things in line. And we know we have a length and a width for a rectangle. It says the length of a rectangle is 15 greater than its width. So greater than its width means we're definitely going to add 15 to the W, to the width, right? That's what we're looking for, sorry. So W plus 15 is going to be our width, or our length, I'm sorry. If each dimension is decreased, so decreased means we're going to subtract. Decrease by 2, so I'm going to take 2 from each one. The area will be decreased by 106. So again, decrease is subtract that 106. But we need to know what the area was before we took 106 away. And that's our original dimensions. So W plus 15 times W, because area is length times width. And when we distribute that W to the W, we end up with W squared. And W times 15 is going to be 15W. So it's W squared plus 15W, now minus 106 with a new change. Find the dimensions. So I know this is the area. Now remember, it's area is length times width. So the area is that long trinomial. So W squared plus 15W minus 106 is equal to 15 minus 2 is going to give me 13. So W plus 13 times W minus 2. All right, I'm going to pause for a minute and let you guys multiply those two binomials times each other and see where you can get with that. Like, so you want to practice doing that. Because I've realized with some of our meets and some of the feedback that it's the basic skills we really need to work on and then attack the actual EOC level questions. So right now what I want you to be doing is multiplying these two binomials together, please. So, all right. So W times W would be W squared. W times a negative 2 is a negative 2W. 13 times W would be 13W. And then 13 times that negative 2 would be a negative 26. We're going to combine our like terms here. So it's going to be W squared plus 11W minus 26 is equal to W squared plus 15W minus 106. Now, we have now run out of space on my paper, so I'm going to grab a scratch piece and keep working down. You're going to combine like terms, because as we've said before, as soon as you see W squared, you need everything on one side. I'm going to just choose to move everything to the left. So I'm going to subtract W squared, and then those are going to go away. I'm going to move my 11W, so I'm going to minus 11W from that 15, which will give me 4W. Then I have 106 equals, and I'm down to that negative 26. Now I want to get that W, because I'm no longer in a quadratic, I want to get my whole number away from that. So variables on one side, constants on the other. So I'm going to add 106, which should give me 4W equals 80. Then we're going to get rid of that 4. How am I going to get that 4 off that W? Yep, and what am I going to divide by? Sounds like a silly question, but sometimes we miss it. Yes, good job, Timmy. Divide by 4. So W equals 20. So the width is 20. And if the width is 20, the original rectangle would be 20 plus 15th. So it was 20 by 35 for the original. And then the new one, after we made our changes, was 18 by 33. So after they reduced it by 2, I should have put OG, original. Okay, so the original versus your new. And hopefully we know the 35 is because we went up here with our width. So length is width plus 15. So that's at 20 plus 15 is where that 35 came from. That was up there. All right. Now mine's pretty hard to see, but this is a 20 and this is miles walked down here. This is money collected. This is 40. This is 20, and then obviously our 0 down here, because if you don't walk anything, you didn't gain any money. So it's the amount of miles walked and the money in dollars collected for a school fundraiser. Which of these best represents the rate of change in the money collected with respect to the miles walked? So there's a little 1, 2, 3, 4. Yeah, there's 4. This is a nice intersection. And by nice, I mean it crosses at a good place for an X and a Y value. So from here all the way up, and then there's one here as well. But whichever one you see, it will reduce itself. If this is 20, then we know that 5 of these have to be 5 each. So 5, 10, 15, 20. So that's where they're getting you on this one, is the way they're counting. This is 20 again, and it's 1, 2, 3, 4, 1, 2, 3, 4. So it's every 5 again, so 25, 30, 35, 40. But if we use the numbers given, so 20 over 5 is one of them, and then 40 over 10 is one of the good points. 0, 0 doesn't help us much. But if I reduce this, 5 goes into 24 times, 10 goes into 44 times. So it looks like if I go, this is money collected per 5 miles walked. So $20 per 5 miles walked. But when it's reduced, it's $4 per 1 mile walked. So $4 per mile walked. And that's again making sure that you know that it's a Y over X, so rise over run. And then just reduced. So $4 per mile. Yep, good job. Good job, good job. All right, number 3, which of the following is the graph of the quadratic function? Now, if this is calculator inactive, you're going to have to think the way we're about to talk. If it's calculator active, I would go put this in Desmos and then compare your y-intercepts, your vertex, and all those good fun things. I know that my constant is my y-intercept, even in a quadratic function. So just like in our linear, when the number without the variable is where it's going to cross the y-axis. So we definitely know it needs to cross the y-axis at a negative 3. So 1, 2, that's a positive 3. 1, 2, that's a negative 3. Positive 3, negative 3. So at that rate, C's out and A's out. Also, knowing this is a positive function, so the front number is positive, also takes A and C out because they're sad faces. Right, so it's either B or D. And then we're going to look at our zeros. So we're going to factor this guy. I need a negative 3. That will add or subtract to give me 2. And if we do it the full one, let's go 1x because it's AX, AX, and A times C is at the top. So 1 times negative 3. Multiples of 3 are going to be 3 and 1. With that said, my B value is positive. So am I going to make the 3 negative or the 1 negative? So if I do negative 3 plus 1, what does that give me? I owe you $3 and I give you a negative 2. What do I actually want? Positive, right? Yep. So we're going to do 3 minus 1 gives us that positive 2. So we're going to make the 1 negative. So that means our factors are x plus 3, x minus 1. Now those are the factors, not the zeros. The factors. To get the zeros or solutions, we're going to take both of those and we're going to set them equal to 0. So how am I going to move that 3 to the other side to get x by itself? Yep. So it's going to be x equals a negative 3. And then I need to move that negative 1 to the other side. So I'm going to add, it's going to be x equals 1. That means that this graph is going to cross the x-axis at a negative 3 and a positive 1. So there's a negative 3. There's a positive 1. This is a positive 1. I'm sorry, negative 1, positive 3. So our answer should be D, because we need that negative 3, positive 1, and then our negative 3 down here. You could also maybe have chosen to do your vertex. Just the x value alone would have helped us solve. So negative b over 2a, that's the x value of your vertex or your axis of symmetry, which would be negative 2. So opposite of our b, 2 times 1, which is a negative 2 over 2, which is a negative 1. And our axis of symmetry needs to be at that negative 1. And this one was at positive 1. So any of those ways, if you don't have your calculator, are the way you could find that graph without a calculator. So you could do it by your y-intercept, your zeros, x-intercepts, root solutions, and or your axis of symmetry. Number 4, which situation could be best modeled with an exponential function? So that the value of a car that loses 6% of its value per year, the cost to purchase different weights of bananas at a store, the total number of miles run by a person who runs 8 miles per day, the path of a baseball hit into the air. Which one do you guys think would be exponential? Yep, definitely A. Loses 6% of value every year, because after the first year, your amount changes. Your starting amount would change because I lost 6%, so then I have a new number, and I'm going to lose 6% of that new number, not off your starting value. The cost to purchase different weights of bananas at a store, usually it's like, I don't know, 75 cents per pound, which means every pound is going to be 75 cents no matter what, right? So each one would be, what would be the unknown would be how many pounds of bananas you have. And then you would multiply it by 75 cents or whatever the cost of bananas are. The total number of miles run by a person who runs 8 miles per day. Again, it's a constant rate of change. So 8 miles every day just means y equals 8 miles times the number of days you did it, and that's how many miles they ran. The path of a baseball hit into the air, as a ball goes into the air, it's going to do one of these. It's going to come back down. And that's a quadratic function. So it's going to start down close to the ground and then go all the way up into the air. So you're going to have a max min. So that one would be quadratic. So B and C would be linear and D would be quadratic. So exponential would definitely be A. Good job. All right, number 5. The expression negative 5t squared plus 40t predicts the height in meters of an object t seconds after a person launches it into the air. Using this expression, how many seconds will it take for the object to hit the ground? So we have an object. This is probably our height. X is I'm using as my t. So this is t because the input is time. As time passes, we're throwing something into the air that's going to make this kind of shape, right? And it says, will it hit the ground, which means I'm looking for my x-intercept. So x-intercept, because the ground is the x-axis, that means we have to factor and solve. Or solve is good too. So if I have negative 5 t squared plus 40 t. Do I have a constant? Is this a binomial or a trinomial? Binomial, right? There's only two terms. That means we're not going to do big star. We're not going to standard trinomial factoring. Is it a difference? Like, is there a minus sign in the middle? No, so it's not differences of squares, so we can't take the square root of the first term and the second term and keep boogieing. So at this point, the only thing left for us to think about is GCF, which you should always think first no matter what. Now remember, the constant is the number that has no variable. So just because there's not a number out here with no variable does not mean it like falls in line. There is no constant in this one. The constant would be 0. So that ball is starting at 0, 0, and then it's going up into the air the way they're graphing it or the way they're modeling it with this function. Now, this front number is in negative, so you definitely want to pull out a negative. You want your x squared, or in this case t squared, to be positive and 1 if possible. What number do 5 and 40 have in common? The largest number they both have in common. What can I divide into 5 and divide into 40? The biggest number I can divide into both. Five times 8 is 40. So let's see if we do it this way. So 5 would be 1 times 5, not 2 times anything, not times 3 times anything, not 4 times anything, and then 5 times 1. So they repeat. So 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8, no 9, and then 10. So looking at both lists, what's the largest number they both have in common? Yep. So that 5 is our GCF. So we pulled out the negative. To get the negative off the front, we're going to pull out a 5. So now I've checked off the negative, I checked off the number, and I'm just going down the list, like checked off the negative, checked off the number. Now I see that I have two variables, two t's right there, because that is t times t, which gives me t squared. Is there a t in the second term? So that means they have a t in common in both terms. So I can pull out a t as well. You want to use your lowest exponent. This has an imaginary 1. So versus 2 and 1, 1 is the lowest exponent. So we're going to pull out just that singular t. Now, negative 5t times what will give me negative 5t squared? So I took out the negative 5, so it's going to be a 1. And I took out 1t, which leaves me with one more t. And the idea, again, is that if I multiplied this times this, I would get that 5t squared. Negative 5 times what is going to give me 40? What can I multiply negative 5 by to get a positive 40? Yep, definitely a negative. Negative 8, good. There's a t out here already, so we don't need a t back here. So I have negative 5t and then 1t minus 8. Now I have factored completely, so now I'm going to solve. So now solve, and when we say solve, that means set each factor. So negative 5t equals 0, and t minus 8 equals 0. Negative 5t, how am I going to solve t and get t by itself? Negative 5t, how are these two combined? This operation, negative 5 and t is multiplication, right? So the inverse of multiplication would be to divide by negative 5. But 0 divided by anything. So we have t equals 0 for the first one. Then I think because we're focused on that 8, we're going to add 8 to both sides because it was a negative 8. So our 8's go away. So T is going to equal a positive 8. So looking at our graph, we already knew our 0 right here. This guy's going to hit the ground at 8. So using the expression, how many seconds will it take to hit the ground? And it says T is in seconds. So you do want to make sure your units of measure are the same. So it's going to take 8 seconds for the ball or item, tell me, launches, just a person, launches an object. 8 seconds to hit the ground. Because you're finding, yep, absolutely, the x-intercepts again. All right, Julie and Jamie go to a bake shop and buy cupcakes and donuts. Sounds like a great start to the day if you ask me. Julie buys 4 cupcakes and 2 donuts and spends $8. Jamie buys 2 cupcakes and 4 donuts and spends $7. How much does a cupcake cost? So Julie buys 4 cupcakes, that's 4 cupcakes, and 2 donuts and spends $8. Jamie buys 2 cupcakes and 4 donuts and spends $7. I'm going to pause and see if you guys can give it your best go, because there's a couple different ways you can do it, but the goal is to find the value of what the cost is for a cupcake. So I'm going to give you a minute and see where you get. We can't just add them together. We got to get something to go away. So we have to get something to cross out to be able to solve for one. Because right there is 2c plus 6d equals 15 is fine, but that doesn't really tell you anything about them. So we're going to change the quote-unquote the font. I need to solve for cupcakes, so ideally I would like to cross out donuts. So is there, what could I multiply one of these by to make them match? So it'd be pretty easy to make 2 into a 4, right? What would I multiply 2 by to make it into a 4? Yep. And I would like them to be negative or opposites, because that way something will cross out. So negative 2 times 4c is going to give me a negative 8c. Negative 2 times 2d is going to give me a negative 4d, which is perfect because I have 4, 4, and one's opposite. And then negative 2 times that 8 is going to give me a negative 16. Now I'm going to focus on just these two. And now I'm going to work straight down and add. So 2c minus 8c is going to give me how much? So 2 plus a negative 8. Yep. So negative 6 cupcake. Our d's went away, which means it's good, so donuts are gone. And then 7 minus 16, or plus a negative 16. Negative 9, yep. So then we divide by negative 6, divide by negative 6. C is going to equal, and we can reduce this. They're both divisible by 3. Positive 3 over 2. But nobody ever tells you that a cupcake costs 3 over 2. 2 goes into 3 one time with 1 left over. So that would make that 1 over 2, which is a half. So cupcakes are $1.50. Now, ideally, these numbers probably are inactive question style. But had it not been inactive, you could take this one and put in Desmos. And then figure out, you do have to use X and Y. So you would need to assign like cupcakes, X, and then donuts, Y. And I would make a little key, especially on EOC day when you have so many questions and so much going on. And then you would solve for X. So X should be equal to 1.5 when you put those in Desmos. So again, if you could set up the equations, you can go to Desmos and type them in, and that's where you would have your 4x plus 2y equals 8, and they can even stay in standard form for that matter. So 2x plus 4y equals 7. And we have 1.5 and 1, which means that we also now know that donuts cost $1 because we know Y is donuts, and then your cupcakes cost $1.50. So if setting up the equation is not the problem, and it's just the solving that we run into issues with, probably 80% of the problems that you're going to see like this are going to be on the calculator active portion. So put it in the calculator and look for the intersection, and then you're ready to go. All right, what is the value of Y in the system of equation? Now, this one is very likely to be a calculator inactive just because it's Y equals. That means this whole thing is Y. So I'm going to do 2x plus 6. We're going to put it in the place of Y. Like Y goes away. We are substituting in negative 1/2 x plus 2 for Y because it says Y is. Equal marks is the same thing as saying is. And if Y is this, then that Y goes away with that. Now, even though that fraction looks pretty wild, we can do this one. 6 times 1/2 x. So 6 times 1/2. And when you multiply fractions, so 6 across the top, across the bottom, 6 times 1 is 6. 2 times 1 is 2. And what's 6 divided by 2? Yep. So that means this is going to be a negative 3x. Sorry, that 1 was negative. And then 6 times a positive 2 will give me what? Yep. 12, and then equals 9. Now we got to solve it, so we're going to clean up on one side first. So combine our like terms. 2x and negative 3x. So if I have $2 and I spend $3, I'm in the whole $1. I need to get my x by itself. So what am I going to move to get x by itself? When I have negative x plus 12 equals 9. Yep, subtract 12. Good job, Emma. Minus 12, minus 12. Be careful, that's a negative 1x. Don't forget about it. That's why I always put the negative 1, because I feel like it's a little harder to ignore versus just a negative symbol. It's really easy to boogie right past it. So equals a negative 12, but x is not by itself. We're going to divide by negative 1 to get rid of that on that x. And so x equals 12. Now that I have x, I can solve for y because the question is asking for y. And luckily, they didn't give us a trickster answer. So now I'm going to do 2 times x plus 6y equals 9. So 2 times 12. What's 2 times 12? Yep. So 24 plus 6y equals 9. We're solving for y. So what are we going to move first? Yeah. Yep. So we're going to minus 24, which is going to give me 6y. 9 minus 24. Uh-oh, something's not right. It would be a negative 15 divided by 6, though, is not going to give us any of those answers. So here we're going to do. We're going to go check our math. I've been known to make mistakes. So the first one was 2x plus 6y equals 9. And the second one is y equals 1/2 with a negative 1/2. Negative 1/2 x plus 2. And our x value is 3. I don't know where we messed up. Oh, 9 minus 12 is a negative 3. I see where I messed up. At the very end, what trash. So you see it. 9 minus 12 is not a negative 12. It would be a negative 3. And then divide by that negative 1, we get 3. So then this all changes. Two times 3 gives me 6. Subtract 6 from both sides. Divide by 6. Y equals 1/2. So big oops on my part. So y does equal 1/2. So it'd be B. Number 8. So more system fun. We need them to match and one to cross out. So the question is, what is the value of x plus the value of y? So it doesn't matter which one we cross out. If you wanted to cross out an x, we just need to make one of them opposite. If we want to cross out y's, we need to make the bottom one, probably more easily, a negative 3. It's already negative, so we just need to make it a 3. Let's go with, do we want to cross out x or y? Yep, absolutely. Good call. Definitely going to use elimination. Obviously, if it's calculator active, you can still plug it in the calculator just as is. I'm going to multiply the second one by 3. It's going to give me 6x minus 3y equals 12. And then I'm going to bring down the one that was there because now I've taken care of this one and changed it. So 2x plus 3y equals 12. And that's just the top one coming down. Now I'm going to work straight down and add. So 6 plus 2, 8x. My 3 y's went away. Equals 24 because 12 plus 12 is 24. So divide by 8. What does x equal? Yep. So then we're going to do 2 times x plus 3y equals 12. And I just took the top equation. You can do either one. So 2 times 3, just give me 6 plus 3y equals 12. We want to solve for y. So we're going to subtract 6 from both sides. 3y equals 6. And then we're going to divide by 3, y equals 2. So x equals 3, y equals 2. Written as a coordinate, it would be 3, 2. But it wants to know what is the sum. So what is x plus y? So what's the answer to this question? You got it. Number 5. 3 plus 2 is 5. I didn't even mean to give you this many systems in a row. Sorry, guys. So what is the relationship between the following two lines? So parallel means, to know if they're parallel, what would have to be true about these lines? How do we know if lines are parallel? Yep, same slope. So we got to check their slope. Same line or collinear means same slope and same y-intercept, right? So same slope and y-intercept. So M and B would be the same if it was in slope-intercept form. Perpendicular. What do we know about perpendicular lines? Opposite reciprocal. Yep. Opposite and flip. Opposite and flip. The math word is reciprocal. But we need it to be both. So flip is easy to remember. Do opposite and flip. Intersect at exactly one point but are not perpendicular. That would be any system that they touch. So basically any system without the current, the things we just listed above. So to get y by itself on this one, I'm going to divide by 3 all the way through. So y equals 2/3 x plus 9 divided by 3 is 3. This one I'm going to move my x over. So it's going to be 18 plus 4x equals 6y. Then we're going to divide by 6 all the way across. Which gets rid of our 6's here. So we end up with y equals 4/6 x plus 3. So looking at that, one, I'm a high school student and I should have done something a lot better than what I just did. But what answer do you think it is? Are they parallel, perpendicular, same line, or just two lines that intersect? They do have the same slope. What about their y-intercepts, though? Because these match at the same. So not only are the same slope, they also have the same y-intercept, which means they're the exact same line. And again, if this was active, calculator active, we can type in 3. We can even type it in exactly the way they give it to you. 2x plus 9. 18 equals 6y minus 4x. And you can see they graphed right on top of each other. If I take the red one away, I can see the black one. Put the red one on, I can see the red one. Black, red, black, red. That means they constantly touch each other. They have infinite number of solutions because every x value you plug in is going to give the same y value in both equations. All right. An account earning interest at a rate of 4% has a principal of, oh, that's not supposed to be a percentage sign. That's supposed to be a dollar sign. That's what I get for typing too fast. $500,000. If no more deposits or withdrawals are made, about how much money would the account have after 5 years? Is this exponential, linear, or quadratic? Because those are the 3 main types of functions we need to know. Exponential, quadratic, or linear. Which one? Just from that storyline. Is that an exponential growth? Is that a positive quadratic? Or is it a positive linear? So if I add 4% to the amount I have every year, will it be the same amount every year that I gain? No, because I'll have more. Like once I put 4% more, once it earns 4%, then that number is bigger, right? So since it's not the same, that means it's definitely not linear. And do you normally, like if you're looking at gaining money that you never touched, like you never took any out or added any, Do you think that money would look like this when your numbers, or even like this, like it goes up, 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 and then all of a sudden it's just going to come down? It's not stock market. Yeah, it's going to definitely be exponential. You're starting at an amount, and then it's going to go up if it's in just a savings account. Yep. So for quadratic, it's not going to go up and then come right back down. That would be terrible. Maybe in the stock market, but it's going to be more zigzaggy. It's not going to be a perfect quadratic for most things. All right, so that means we know that it is going to be A1 plus or minus our rate, our percentage as a decimal to the amount of time we're tracking. So what's our initial amount or our starting amount of money here? What does it tell us is our starting amount? So we start and invest $500,000. Now, is it 1 plus or 1 minus? It says earning. So does that mean it's a plus or a minus? Yep. And then we're going to take our 4% and we have to turn it into a rate, which is a decimal. So we're going to divide that 4 by 100 or take that decimal and move it 2 times to the left. 1, 2. So there's a 0 point. So 0.04, which we're going to put right here. And then how long is it asking us to track it? Good job, Timmy. Yep. So for 5 years. So there's going to be 5 right there, and then we're going to solve it. And you can plug it in your calculator just like that. So you can plug a calculator or Desmos, whatever you have available to do your computations. So 500,000, 1.04 raised to the 5th power, 608,326. And it says about how much. So it doesn't have to be perfect. So our answer would be which one? C. They just knocked off the $26. I'm not really sure why, but appears they did because it said about. So if it says about, don't sweat it if your answer is not perfect. That means it's getting close to that much. All right, number 11. 2 times Antonio's age plus 3 times Sarah's age equals 34. So 2, that means times Antonio's age plus 3 times Sarah's age equals 34. Sorry, trying to write and read. I was having a bit of an issue. So 2 times Antonio's age plus 3 times Sarah's age equals 34. I don't know about you, but as soon as I see that, this looks like we're going to start doing another system. All right, second sentence. Sarah's age is also 5 times Antonio's age. So Sarah's age is, so that's Sarah's is, and it says 5 times Antonio's age. So Sarah equals 5A. So that means S is 5A. So we're going to plug it in right there, and then we're going to solve it. So 2A plus 3. We're getting rid of our S because our second equation says S is 5A. So it's going to be 5A. I'm going to give you a minute, and I'll see if you can tell me what Antonio's age is. Give you a minute to tell me what Antonio's age is. Yep, good job. 2 years. So Antonio is 2. Is that the answer to this question? Like this EOC question? No, right? So if I know that Antonio is 2, it says Sarah is 5 times Antonio. So Sarah is 5 times Antonio. So how old is Sarah? Yep, good job. 10 years old. So Sarah's 10 and Antonio's 2. I'm trying to tell you, if it's multiple choice, that 2 answer is going to be there because they get real excited that you got excited. All right. Now, number 12. This is not hard. A lot of people miss it. So here's what I need you to hear me. The table above shows average weight of plankton after several weeks. What is the average rate of change in weight of plankton from week 8 to week 12? Now, that does not mean the entire table. If they notate in an EOC question 2 specific times, so week 8 and week 12, then you are going to only use those 2 coordinates to find your average rate of change. And hopefully as soon as you saw the word average rate of change, you know that is slope, which is rise over run, or y minus y over x minus x. And I think it's y2, y1 is what a lot of 8th grade teachers taught you. As I've told you before, I'm a big stack them, subtract them, and all that good fun stuff. So 8.04, 12.49. Stack them, subtract them. So 8 minus 12, give me a negative 4. Negative 0.04, I'm sorry, 0.04 minus 0.49, I'm going to give you a negative 0.45. So I stack them, subtract them, y goes on top. So negative 0.45 divided by 4. Definitely want to plug that in your calculator. Negative 0.45 divided by 4 is at 0.11. Oh, because I left off the 4, negative on the 4. So I was like, why am I getting a negative and they're not? So the 11.25. 0.1125. D. Now, if you had run the entire table in your calculator, that answer is there as well. So again, hear me out. If they make note to 2 specific coordinates in the table, because remember, a table is just a list of coordinates, then just use the 2 that they note. So this is a list of coordinates. So just use the 2 they asked for. So week 8, week 12. If they had said week 9 and week 12, then you would have used 9 and 0.07. So if they make note to 2 and don't just hand you a table and ask you for the rate of change, definitely pull those guys out. Okay, this was a call out yesterday when we were doing our live class. Was a little bit of help on this one, but it wasn't the exact same question. So a triangle has vertices of 1, 3, 2, negative 3, and negative 1, negative 1. So this is my triangle. What is approximately the perimeter of the triangle? Perimeter means the distance all the way around, right? None of these lines are straight. So we're going to turn each one of them into a triangle and use Pythagorean theorem. So we're going straight up and straight across. So that's going to be 2 and 4. So remember Pythagorean theorem, as a triangle, that means I'm solving for my hypotenuse here. And I have a height of 4 and a run of 2. So 2 squared plus 4 squared equals c squared or x squared, whatever letter variable. Just know it's something squared. So 2 squared is 4. 4 squared is 16. So 20 equals x squared. What is the inverse of squaring something? Yep. To undo squaring something, we're going to take the square root. So I know this side is the square root of 20. We're just going to leave it like that for right now. And then we're going to go do the other side. So this one is 1 over 1, 2, 3, 4, 5, 6 to get down. So 6 by 1. So I'm going to do 1 squared plus 6 squared equals x squared. So I'm solving for the other side. 1 times 1 is 1. 6 times 6 is 36 equals x squared. 37 equals x squared. And again, like you guys said, the inverse of squaring something is taking the square root. And we're leaving it as these big numbers with the square root just to make sure when we're done with it that we didn't round inappropriately like as we went along. Then we're looking at the next one. 1, 2, 1, 2, 3. So 3, 2. So we're going to do 2 squared plus 3 squared equals x squared. So again, we're solving for the hypotenuse. So it's 2 times 2 is 4. 3 times 3 is 9. So it's going to be 13 equals x squared. Again, you're going to take the square root to get rid of the x squared to get x by itself. So it's the square root of 13 here for this side. So then you're going to add the square root of 20, because it says the perimeter, plus the square root of 37, plus the square root of 13. Definitely want to use a calculator. It says approximate, which means it's probably not going to be dead on with all those decimals. That makes sense. Your square root button, I know, is something I've had to teach in the past. If you don't use Desmos, and you will get a calculator that day, it's behind your x squared button on the left-hand side of your calculator. So underneath the y equals this 1, 2, 3, 4, fifth button down is the square root. You would hit second and then that button in case you want to use your calculator that day on the day of our EOC. So 14.16. So which answer is the closest to make it approximately correct? Yep, it is B indeed. So the perimeter of that triangle, so if I sat on this point and started walking all the way around, is going to be about 14 units.